Hi, I'm Marita Davison. We're back in the United States after our trip to Bolivia. We're here at Cornell University and we're about to begin the lab portion of our research. So as soon as I get to the lab, the very first thing that I want to look at are the algae samples that we took. And I've got the algae samples right here. These are the samples that we took on those filters, and we put them in these canisters so that we can do what's called an extraction. Basically what we're doing is we're putting them in a bath of ethanol that will then extract the chlorophyll from those algal cells that are on that filter. We're looking at algae because flamingos are eating algae, and they're eating lots of algae. And we want to get a sense of whether or not they're having an impact on the ecosystem. And we're starting with algae because algae are at the base of the food web. And so they're food and resources for pretty much anything else that is living within this lake. So if flamingos are impacting algae, then they're probably impacting a lot of other things within the lake. So the first thing we do is draw out an exact volume from each one of these canisters. And I'm going to draw out 3 mils, and then we run the sample, and it's really quick. So you get your first reading within about 10 seconds. I type it right into my database here. So once we've done our chlorophyll analysis, the next thing we want to do is do an analysis for organic matter. So the process here is pretty simple. We've got our sample in an envelope, and again it was collected on a filter. This filter is kind of wet, so the first thing we need to do is dry it out. We dry it out for 24 hours in what's called a drying oven. Then what we do is we weigh that dry sample. So we take that to a balance to get a really precise reading of the weight of that sample. So when we get a final number that gives us how much organic matter was burnt off of the sample, that tells me how much organic matter was on this filter when we took the sample. The next and final step here is to look at our algae samples in a lot more detail. So we've already gotten an idea of the total biomass, so how much of it's there, but we also want to know who's there. And in order to do that, we have to look at these samples under the microscope. So here we've got a sample of algae that we have preserved, and so we need to take out a bit of the sample and put it into the special slide, and then we just look at it under the scope. It's important because other things are eating algae as well, and so if the composition of that algal community is shifting, is changing because of flamingo activity, that's something that we want to know because it might have an impact on other things that are depending on algae as well. We're also doing an additional study where we are trying to track flamingos. We want to know where they go, how long they stay there, and how they distribute themselves within certain lakes. So to do that, we've actually had to use technology because traditional observational techniques, just going out there with your binoculars and observing them, is really impossible with these birds. They're extremely finicky, so the moment they sense your presence, they start to fly away. So what we've had to do was we've had to use what's called a photo monitoring technique, and basically we use these little things here. These are what are called camera traps. They're digital cameras that are fully programmable, so we've set them up at our lake in a number of different locations, and we've set them up so that they take pictures every day and every 3 hours. Personally, I think it's really important because these birds are really threatened, and we need to be able to determine where they go. When we know where they go, we know that that's where we can start to protect them. What makes this approach extremely useful is that we can leave these cameras out for weeks and sometimes months at a time. They run off batteries, regular batteries, and then they record the images to these compact flash cards. And then all we need to do is go back to the site, pull out these cards, and then we have our data. I load them up into what's called a geographic information system. So the reason I'm using geographic information systems and not any other kind of program is because I've been able to mark our points with a GPS. So I take this GPS out when I go into the field, and what that allows me to do is, because the GIS gives this point in the image a place on the planet. It essentially says, this is where you are on the planet. Then I can do things like measure distances. I can measure how far they are from each other, how far they are from the shore. And so it really brings in this spatial element that otherwise wouldn't really be able to do at all. This lets me just set the camera up and leave it. I'm not disturbing the birds at all when the cameras are snapping. And I'm also taking data over a long period of time. And because these birds are in lakes that are in extremely remote and very difficult environmental conditions to work in, this is a huge advantage for me because I don't have to sit out there in the cold, in the rain, in the wind, taking notes. I can just let the camera, the technology, do the work for me. In my mind, when we discover something, it's about that. It's about the discovery of things. And because these places are really not studied, we don't know much about them, any little thing is going to help us understand what's going on there. So it's exciting to feel that we're able to contribute to what people know about these places, and allow future scientists, future people who are curious about the natural world and curious about these places in particular to go out and explore for themselves.